Let's go quickly to the previous slide from the previous lecture on the paradoxes of plurality voting. I mentioned spoiler effects, but I didn't explain what this means. In this particular case, we had two candidates who were very close. Their supporters were very similar, and they competed. They both competed in the elections. So if any of them withdrew from those elections, the other one would be the winner, because they both competed. The other candidate was the winner. So in this case, if we have something like that, then we call both candidates, actually in this case, were spoilers for the other candidate. So Alessandri was the spoiler for Tomic, because if he had withdrawn from the elections, Tomic would have become the president, and vice versa. So spoilers appear from time to time in politics. In American politics, the most famous spoiler was Ralph Nader in 2000 elections, because with this spoiler, Albert Gore was not elected the president. Without him, he would have been elected the president. So now let's go back to the Electoral College. And let's recall what are the rules for the Electoral College. So this is the rule used in the United States to elect the president and vice president. And this is our definition, general definition. Voters are divided into subsets. We call them states in this case. A subset K has some corresponding number V of K electoral votes. In our case, this is the total number of senators and representatives. In addition to this, Washington, D.C. has 3 votes, 3 electoral votes. A candidate who obtains a plurality of votes within the subset K, so a plurality within subset K, wins all electoral votes from the subset, with a few exceptions from this rule. I think 3 states deviate from those rules. The candidate with the greatest number of electoral votes is the winner, with some possible modifications. Actually, we need, in the United States, the majority of electoral votes. If there's no majority, then there are some procedures, tie-breaking procedures in place. All right, so now the problem is, a real problem with Electoral College is that election inversions happen. Call them election inversions, electoral inversions. This means that a candidate who is favored by a plurality or even a majority may lose elections. And such failures happened quite a few times. In 1876, the majority winner lost the elections. In 1888, 2000, and 2016, the plurality winner lost the elections. The loss was quite substantial, as you remember. Mrs. Clinton won, I think, 2.8 million more votes than Mr. Trump. How can it happen? Well, this is an example from Wikipedia that explains how this could happen. Unfortunately, if you see this in black and white, then those 2 colors, red and blue, will be looking the same. But let's assume that you are seeing this those colors. We have 5 states in this example, and as you see, 25 votes for the blue guy. Or maybe actually it is a good idea to use the correct color. Okay. Blue receives 25, and the red lady receives 20. But red wins the elections 3-2. Red wins 3-2 in electoral votes. So despite blue winning more votes, red wins the elections. And the driving force here is that red wins by a narrow margin in just a small, with a narrow majority of states, while blue wins in almost one half of states with a huge margin, so has surplus votes in those states. This is actually what happened to some extent in the 2016 elections. Mrs. Clinton, for instance, won in California by a huge number of votes, and those votes were essentially wasted in some sense. A similar example in our standard notation, and a simpler example, I think this is the simplest actually example that we may have, is that we have 3 states, 3 voters per state, and 2 candidates X and Y. In state A, 2 votes for X, 1 vote for Y. X is the winner. In state B, the same story. X is the winner. In state C, 3 votes for Y, and Y is the winner. So X gets 2 electoral votes. X is the winner in elections. But if we count all the votes, then there were 2 votes for X here and 2 there. For Y, 1, 1, and 3. So 1 won more votes than X. More votes than X. And this is pretty disturbing, but actually the problem may be much more serious. And we can ask how serious this problem may be. And it turns out that for any majority P that is just smaller than 3/4, we can easily create an example, some number of states and some number of voters, such that a candidate supported by P may lose. If we have symmetric states, then any number smaller than 3/4 can be reached by the loser, any proportion of votes. What is the idea here? Well, okay, I will show you a graphical argument without really going into mathematics. It's not extremely difficult, but I think that the graphical argument is sufficient. This is how we'll denote voters for X, supporters for X, and for Y will be white. So now we have to construct states such that X would be the winner. X is the winner. X is the winner in those states. And if this is 1/2, then X would win just slightly more than 1/2 of votes. And the same here. Just slightly more. So this is state 1, state 2, and so on. And this will be our state let's see, okay, slightly more than 1/2. Maybe K plus 1, okay, K plus 1. We will see in a moment why K plus 1. Now, Y is the winner in those states. And Y wins all the votes in those states. all the votes in this state, which is k plus 2, k plus 3. And now two k plus 1. So why is the winner in exactly k states? So we have 2k plus 1 states, and in k plus 1, x is the winner. X is the winner in k plus 1 states. So x is the overall winner. So x wins the elections, while y wins here about slightly more than 1/2 of all states and almost 1/2 of votes. So close to 1/4 of votes, plus in the states where y is the winner, plus close to slightly less, but close to 1/2 of votes. So this means that y wins almost 3/4 of votes. Why almost? Well, we are not going into the mathematical details, but with this setup, we cannot reach 3/4. We cannot, but we can do this for any number smaller than 3/4, with a sufficient number, large number of states and voters in those states. But if we have states that are not symmetric, I mentioned that those states in this example are symmetric, but some states are smaller, some states are bigger. This is the case with the American states. Then actually one of my students calculated that this number may be even bigger, that the winner may win even up to 78% of all votes and lose the election. So we may have a loser with 78% of all votes because of those nonlinear effects due to different sizes of different states. Well, fortunately, this is very unlikely to happen. If this happened even in America with the strong democracy, there would be coup d'etat. The system wouldn't survive this kind of situation. If 4 voters out of 5 voted for the loser. But fortunately, this is very unlikely. But still, it shows you the potential for abuse in the Electoral College. And of course, the problems with election inversions happen. They are not really some abstract examples. Now, if you take a look at the distribution of electoral votes in 2016 elections, Mr. Trump won 304 electoral votes against 227 electoral votes of Mrs. Clinton. So they won those votes, but there were many votes, unfaithful votes, as they are called. So the electors deviated from what they should be doing, and they voted for other candidates, for Mr. Sanders here, for the spotted eagle here. What is this? What sort of nonsense is this? 3 votes for Mr. Powell, 1 for Mr. Paul, for Mr. Kasich. So you see, and this is also one, in this case for Mr. Trump. Well, you see that there were many deviations. So this is a bad system. sufficiently bad because of the problem with election inversions. And then, in addition to those problems, we have the problem with electors who may actually deviate from what voters tell them to do. So 100% of voters votes for X, and still our elector in the States says, I want to vote for a spotted eagle. This is total nonsense. Sorry.